Hey, today I'm going to discuss about the prompt engineering. Um, it isn't about clever tricks, it's about structure. In this video, I'll break down the 7 pillars that turn large language models from unpredictable into reliable. When thinking about a large language model input and output, a text prompt, sometimes accompanied by other modalities such as image prompts, is the input the model uses to predict a specific output. You do not need to be a data scientist or a machine learning engineer. Everyone can write a prompt. Moving to the next. So why do we need a prompt? Why prompt engineering matters? LLM do not think like humans. They predict the next token. Your prompt defines the path the model takes, which is why precision matters. So small prompt changes can bring big output shifts. So prompting is an iterative process. Now looking at the 7 pillars of prompt engineering, it's intent clarity, context and framing, output specification, examples, reasoning control, model configuration, iteration and evaluation. So it's about now these are the 7 pillars shown up consistently in production-grade AI systems and modern research, including Google's Gemini guidance. Before going on to the nitty-gritty details of 7 pillars, let's think about a bad prompt. So let's say we have a prompt to say this is a vertex cloud which is now I've given a prompt to say like tell me about a climate change. So it has brought up like so much details. It's not a good prompt because there is no scope, no output format, no audience, no intent clarity. Hence it fails. However, let's say I've changed the prompt to so explain climate change and sorry, I think it's let me bring it down. Okay. Explain climate change causes and in 3 bullet points written for a non-technical audience with no more than 20 words per bullet. So how does it work? Because it's a clear task, defined output, and it's constrained verbosity. So this is a zero-shot language model. So it's important to understand how it works. So clear task, defined output, constraints, and verbosity. Likewise, you have classification and deterministic models. Like, for example, if you're asking, is the review good or bad? The movie, and you've given a bias that the movie was disturbing but unforgettable, it fails because it's ambiguous labels, no output constraint, conflicting sentiment words. So, but a good prompt would be classify the following review. Like you could say, like instead of asking for just for a review, you could say, you know, something like classify the following review as a positive or negative, something like this, or neutral, return only the label in uppercase. Okay, so the movie, so it works because you are giving explicit label set, output constraint, remove stylistic variance. So like that, you can, it all depends on the context, like whether it is a creative or high temperature model, or you could go for other modes, reasoning heavy models, so like requiring math, logic, analysis. So and if it's a code generated model, you may have to give a bash script which works for the codes, because you're giving explicit steps, language specified, and output constraint. So there are other is like agentic tool, like using models like a React style. So again, the good prompt would have enable reasoning, action loop, separate thought from answer, and it reduces hallucination. Okay, let's move on to the next bit, which is like our core about pillar 1. So intent and clarity. So if the model does not know exactly what you want it to do, it will guess. So clear intent reduces ambiguity and hallucination. So the less noisy, the better it is. So clearly define the task, define what success looks like. And the other one, pillar 2, is system prompts. It's context and framing. System prompt sets global rules. So context activates the right knowledge inside the model. Change the role of framing can completely change the output quality. So pillar 3 is output specification. Define format. Maybe like if you're a developer, you might need the content to be in JSON files, bullets, tables. So control the length and style. So pillar 4 is example, like few shot prompting, which we discussed. It's one of the most powerful techniques. So training dataset, example act like a training dataset inside the prompt. So if you give an example, it acts as a training dataset. And pillar 5 is reasoning control, chain of thought, step back prompting, tree of thoughts. For reasoning tasks, asking for the answer is not enough. You must control how the model reasons step by step. So you need to give the thought process how it needs to do as a next step. And pillar 6 is model configuration. So temperature controls randomness. Even a perfect prompt can fail with the wrong temperature. Prompting configuration always go together. And pillar 7 is prompt engineering is never done as models evolve. So it's not one-off. So the models evolve, your prompts must also evolve. The test and refine prompts, document prompt versions. So it's a best practice to document versions, adapt to your model updates. So that's all about the prompts. So hope it's helpful. And the key takeaway is good prompting isn't magic. It's repeatable engineering discipline. Thank you for listening, and do share and subscribe if you would like, if you like these kind of videos. And also I'm going to add some good prompts onto the comments box so that you can have a look at them. So I'll try and produce a cheat sheet. Thank you for your time.